All right, so I'm just going to go through the equation of a line examples which are in your book. Okay, so just a few more different types of questions that we need to be able to do using the equation of a line. So example 1 here, I'll just talk through what's in the book and then I will do the other examples that are in the chapter. So example 1 here says a line contains these 2 points. Find the equation of a line. So to get the equation of a line, you need a point on it and you need the slope. So we're given 2 points. We use that to get the slope. And in this example, it's minus 9 over 2. So that gets subbed into this formula along with one of the points. And they give us the equation of the line y plus 1 is equal to minus 9 over 2 on x minus 5. Okay, it would be more common in a question that it would say something like give it in the form ax plus by plus c equals 0, in which case you'd need to multiply that out, move everything over to one side equals 0. So they leave it like this, but it's more common, as I said, to multiply it out, put like terms together. As I said, just pay attention in exam questions to what form they might want the equation of a line in. Second part here, then they look for the equation of a line which goes through point A. So we know 5 minus 1 is on this line. And I'm told it's perpendicular to the line in the first part. So if the line in the first part had a slope of minus 9 over 2, then the line in this part, because it's perpendicular, has a slope of plus 2 over 9. Okay, so the the slope of a perpendicular line is flipped upside down and the sign is changed. Okay, so minus 9 over 2 here, so the perpendicular one is plus 2 over 9. They're looking for the equation, so again, that just goes into the equation formula with one of the points, and again, they just leave it there without multiplying it out. All right, so as I said, I've got a video going through how to use that y minus y1 formula. So if you're still a little bit unsure on that, have a look at that video again. Just turning over here, I have a little bit of information here, just kind of going through the different forms of the equation of a line. So y minus y1, that's the formula we use to get the equation of a line. Y equals mx plus c, we use that to get the slope, so we can read off the slope if it's in that form, and also where it crosses the y-intercept. So if y is on its own without a coefficient, well then whatever is in front of the x is the slope, and it crosses the y-axis at 0, c. So the example they give here is y equals minus 2x plus 5, slope is minus 2, crosses the x-axis, crosses the y-axis at 0, 5. All right. The last form, so this is kind of standard form here, ax plus by plus c equals 0. So everything moved to one side and equal to 0. That's standard form. I would say that's the most common form you're asked to give the equation in. If you have the equation of a line in that formula, well then the slope is minus a over b. So minus whatever's in front of the x over whatever is in front of the y. You can learn that off. You can always get that slope from just rearranging this and getting rid of the coefficient in front of the y by dividing across and using this. All right, but if you remember that if it's in this form, you can get the slope that way. That's great, but you can always just manipulate this, move stuff around, divide across, get it into this form, and then you know the slope is what's in front of the x. All right. Just on to example 2 here, and I'll just start working through these examples, as I said. So if the point minus 2k belongs to that line, find the value of k. So if a point belongs to a line, then it will satisfy the equation of that line. It means if I sub in here, it will equal to 0. So if I sub a point in here for x and y and it equals to 0, that means that point is on the equation. In this example here, I am told minus 2k is on the line. So I know if I sub minus 2k in there, I should get 0. All right, and then k will be my only unknown and I'll be able to solve for it. So instead of 7x, it's going to be 7 on minus 2 plus 3. Instead of y, it's going to be k because that's the point I'm subbing in. minus 1, and that will be equal to 0 because I'm told that point is on the line. 7 times minus 2 is minus 14. 3 times k is 3k. Minus 1 equals 0. Minus 14 minus 1 is minus 15. Bring it over, it becomes plus 15. So 3k is equal to 15. Divide across by 3 then, and k is equal to 5. All right, so my point was minus 2, 5. All right, you could check that again, or as I said, just to kind of prove the point, if you sub minus 2, 5 into that equation, it should be equal to 0. So let's just do that quickly. 7 times minus 2 plus 3 times 5 minus 1 equals 0. 7 times minus 2 is minus 14. 3 times 5 is 15. Minus 1 equals 0. 15 minus 14 minus 1 is 0. 0 equals 0. That point is on the line. All right, that's just me checking my answer. You don't need to do that as part of this example. Next thing I'm going to do here is example 3, and this is just about plotting lines or sketching lines. So if you're asked to plot or sketch a line and you're not given points, you're not maybe given a domain to work in, a series of x values to sub in, I would say the easiest 2 points to find to sketch a line are where it crosses the x-axis and where it crosses the y-axis. So sub in 0 for y, get the x value that goes with that. Sub in 0 for x, get the y value that goes with that. There's your 2 points. And then you can sketch your line. Okay, so to sketch a line, you need a minimum of 2 points. You can always get a third just to kind of double check your answer, or just as a kind of a check. But for this one here, I would just get 2 points, and I'll get those 2 points that I mentioned previously. So I'm asked to plot the line 3x plus 2y equals 9. That's all the information they give me. They don't give me any points to plot or anything like that, or any x values to use. So as I said, I'm going to go where it crosses the y-axis, where it crosses the x-axis. Okay, so it crosses the y-axis where x is equal to 0. So let's sub 0 into this equation for x. So that's 3 times 0 plus 2y equals 9. 3 times 0 is 0. So I just get 2y equals 9. So y is equal to 9 over 2, or 4.5. So I subbed 0 in for x, and I got 4.5 out as y. So that's the point 0, 4.5. So that is on the line. Then I'm going to sub 0 in for y. All right. So 3x plus 2 times 0 is equal to 9. So 3x, 2 times 0 is 0, so it's just 3x is equal to 9. Divide both sides by 3 and you get x is equal to 3. So when y is 0, x is 3. So that's the point 3, 0. So there's 2 points on this line. So if I just put those onto an xy axis, onto a coordinate plane, I will be able to sketch that line. So just doing it, I'll just do it kind of freehand here. You should do this using a ruler if you're doing it. My y needs to go up as high as about 5. My x needs to go out as far as about 3. So So 5, 4, 3, 2, 1, down to minus 1, and then my x to minus 1, 1, 2, 3, 4. So 3, 0 is on the line, 0, 4.5 is on the line, and again you should do this using a ruler, but just joining those up. That's a sketch of the line 3x plus 2y equals 9. All right, so it crosses the y-axis where x is equal to 0. It crosses the x-axis where y is equal to 0. All right, that's kind of an important thing to remember. It comes up a lot in different parts of the course. All right, so on to my next example now. which is around the intersection of lines. So this is something you've seen at Junior Cert. We would have mentioned it and done it in an algebra chapter earlier on in the year as well. Okay, so to find out where two lines intersect, you have two main methods of doing it. You can either draw the two lines and then just read off the graph where they intersect, or you can do it using algebra, using simultaneous equations. And that is generally the quicker and better way to do it. Okay, and we're going to see why it's a better way of doing it on this example here. So I've got the line L with equation 2x plus 7y equals 8, and the line K with equation x minus 3y is equal to 5. It says find by calculation the coordinates of the point of intersection. I would say by algebra will be a kind of more common way of giving you that prompt or asking you to do it using simultaneous equations. So let's just draw up our 2 points. This is example 4. So I've got 2x plus 7y is equal to 8. And I've got x minus 3y is equal to 5. I think the x is the quicker one to get rid of here. If I just multiply that bottom equation by minus 2, I'm going to have 2x there and minus 2x there. If I wanted to get rid of the y's, I'd need to multiply the top one by 3, the bottom one by 7. It's not much more work, but it's a little bit more work. So let's take the easier route and just multiply this bottom one by minus 2. So x multiplied by minus 2 is minus 2x. Then minus 3y multiplied by minus 2 is plus 6y. And 5 multiplied by minus 2 is minus 10. So don't forget to multiply everything by what you're multiplying by. I don't need to change anything in the top equation. So it's just 2x plus 7y is equal to 8. So let's subtract these from each other. 2x minus 2x is 0. That's why we're doing this, to eliminate one of the letters. 7y plus 6y is going to be 13y. 8 minus 10 is minus 2. So I get 13y is equal to minus 2. So y is equal to minus 2 over 13. All right. Don't forget, you're looking for the point of intersection, not just the x coordinate of intersection. So you just sub this back in to get an x coordinate. Okay, I think this second equation here will be the easier one to do because it's already got x on its own in it. Okay, so it gives me one less thing to worry about when I'm solving for x. If I use this top equation here, I'd end up having to divide across by 2 at the end. So I think this is going to be a little bit quicker. So let's use that second one. So x minus 3y. So x minus 3 times, instead of y, I now know y is equal to minus 2 over 13 is equal to 5. All right, so x minus 3 multiplied by minus 2 is plus 6 over 13. So if you're multiplying a fraction by a whole number, it's the top of the fraction you multiply by the whole number. So minus 2 multiplied by minus 3 is plus 6. If that tends to trip you up, just do it on the calculator, okay? So minus 3 multiplied by minus 2 over. I've written 10, so yeah, sorry. So minus 3 multiplied by minus 2 over 13 equals plus 6 over 13. All right, that equals 5. Bring the 6 over 13 over, so you've got x is equal to 5 minus 6 over 13. You can get your common denominator and do that by hand or just on your calculator. 5 minus 6 over 13 is equal to 4 7/13, or else 59 over 13 is how I think I'll write it. So x is equal to 59 over 13. So your point of intersection is 59 over 13 minus 2 over 13. So there's your point of intersection. The part 2 says, explain the limitation of using the graph to find this point. Well, if you try to find that point using a graph, what's 59 over 13 equal to? It's equal to 4.53846. So that's kind of hard to read exactly off a graph. Okay, the kind of best you're going to get is kind of roughly 4.5, I would say, or it would also be very easy for your graph to go a little bit off and for it to look like 4.4 or 4.3 or 4.6 on your graph. So by doing it using simultaneous equations, by doing it using algebra, we get the exact accurate answer. Okay, I think it's also quicker than drawing the two of them. Okay, but it's also definitely more accurate, especially when you have a case like this where your 2 points are not whole numbers. Okay, they've kind of got a few points after the decimal. If I was to do minus 2 over 13 as well, that's equal to minus 0.1538. That would be quite tricky to read off a graph. Okay, it'd be quite close to 0, but a little bit to the left, but I wouldn't really, or a little bit below it, I wouldn't be too sure exactly where it is. Okay, so algebra definitely gives you the more accurate answer there, as well as I said, as I think a quicker answer too. Last example then in this chapter is just around parallel and perpendicular lines, and it's just a little bit that we need to go through here first, and it is telling me that any line parallel to 3x plus 2y equals 7 is in the form 3x plus 2y equals k. So it was in the form 3x plus 2y equals something. Okay, so if that's your original line, 3x plus 2y equals 7, well then 3x plus 2y equals 5 is parallel to that line. 3x plus 2y equals minus 10 is parallel to that line. Okay, 3x plus 2y is equal to minus 100 is parallel to that line. Okay, so as long as the x term and the y term are identical like that, the constant doesn't really matter. Okay, this is telling me that they are parallel lines, and the constant over here, that just kind of shifts the line upwards or downwards. Okay, controls the vertical shift of the line, but it's these two here are telling you that the slope is the same. Okay, and if you remember when I said when it's in the form ax plus by plus c, the slope is minus a over b, so the slope is minus 3 over 2. Okay, so that's y. Right, the kind of parts which give me the slope are the same, even if what's over here is different. Okay, obviously it doesn't just apply to 3x and 2y. So let's say you had 5x minus 7y equals 20. Okay, give me 3 lines which are parallel to that. Well, 5x minus 7y is equal to 5 is parallel to that. Okay, so the x and the y part are the same, it's just the constant that is changing. 5x minus 7y is equal to minus 14 is parallel to it. 5x minus 7y is equal to 1 is parallel to that original one. Okay, so you need to remember that. All right, so if the x and the y parts are the same, they are parallel. All right, it's just the constant over here that changes. We also need to remember something similar but a little bit different about perpendicular lines. So if I take the same line, 3x plus 2y equals 7, well, a perpendicular line is going to be in the form, you flip the coefficients, so instead of 3x and 2y, it's 2x and 3y, and then you change the sign on one of them. So if I change the sign on that, then this one will stay positive. Or, so flip the coefficients, so 2x and 3y, I will leave this one positive, make that one negative. Okay, so if you're given the equation of a line, well then the equation of a line perpendicular to that will have the coefficients on the x and the y switched, So instead of 3x and 2y, it's 2x and 3y, and then just one of the signs will change. All right, so I just changed the x here, I just changed the y here, and then the constant again is k. Okay, it can be anything. All right, so if it's 10 or 12 or minus 20 or minus 200, it doesn't really matter. It's still a perpendicular line. So it's just these parts that give us that information. All right, so again, just to kind of do an example, if I do 4x plus, or I'll say 4x minus 9y equals 8. Okay, so that's a line. Let's give 3 lines which are perpendicular to this. All right, well, if they're perpendicular to this, instead of being 4x and 9y, they are going to be 9x and 4y, 9x and 4y, 9x and 4y. Okay, so you flip them and then you change one of the signs. So this is plus and this is minus. So if I leave this as plus and make this plus, I've changed one of the signs. So let's just say that's equal to any number at all, 12. All right. Second one then, so I'm changing one of the signs. So let's leave the y as negative and make this one negative as well. All right, and equal to, doesn't really matter, we'll just say 20. 9x and 4y, so I've switched the coefficients and now just change one of the signs. So I will leave the x as positive and change the y again. So make the y positive, and that's equal to, we'll say, minus 2. So there, 1, 2, 3 lines which are perpendicular to this. I know they are perpendicular because I have switched the coefficients on the x and the y, changed the signs on one of them, and then just change the number over there. Or you could have left it as 8 and you still have a perpendicular line. All right, but any number over here is still going to be perpendicular. So just the couple of examples then that they have on that. Example 5, part 1. Find the equation of a line through 2 minus 3, which is parallel to 3x plus 4y equals 1. So if it's parallel to this line, 3x plus 4y equals 1, well then its equation is going to be in this form. 3x plus 4y equals some number. Okay, so any line parallel to 3x plus 4y equals 1 is going to look like that. I'm asked for the equation of a line which contains this point, so let's sub that point in for x and y. So 3 times 2 plus 4 times minus 3 is equal to k. So 3 times 2 is 6, minus 12 is equal to k. 6 minus 12 is minus 6 is equal to k. They want the equation, they don't just want the value of k. So my answer is equal to 3x plus 4y equals minus 6. All right, so that's the line parallel to 3x plus 4y equals 1 that contains that point 2 minus 3. The second part of this, so a line which contains that point and is perpendicular to this line, well, if it's perpendicular to 3x plus 4y equals 1, well then switch the coefficients on the x and y. So instead of being 3x and 4y, it is going to be 4x and 3y, and then change one of the signs. So they're both positive in the original equation, so I'll just change the sign in front of the y, and then that is equal to any constant, so just equal to k. But what am I looking for? I'm looking for the equation of a line that contains this point here, so you can sub that in for x and y. So 4 times 2 minus 3 times minus 3 is equal to k. 4 times 2 is 8, plus 9 is equal to k. 8 plus 9 is 17. So your answer, your equation is 4x minus 3y equals 17. All right, so you should be able to do all the questions now in exercise 19.4, and you're able to do that bit more now with the equation of a line than we were when we were just looking at the two equations in the log tables.